So the last thing we're going to cover is separation of variables. And separation of variables is one very simple technique to solve differential equations. And it's actually the only technique you'll need to know for AP Calculus. AB or BC is separation of variables. Now, if you move on in math classes, you'll learn more advanced techniques. There's whole courses dedicated to solving different kinds of differential equations. But separation of variables is the idea that what you want to do is you want to write the equation like this. dy dx is equal to y squared minus y. And the whole goal is to move the dx to the other side, okay? And then move all the y variables down here. Okay, so first I'm going to move dx up to this side, so I'll have dy is equal to y squared minus y times dx. I get to treat this like a fraction and then move this down to here. dy over y squared minus y is equal to dx. Because I can divide by. So you're basically just doing multiplying and dividing is all you're really allowed to do. And if you can separate the variables like this, then you are allowed to do, then this is called, yeah, so it is possible in this case. In this case, this technique, you won't be able to solve this integral because the way you solve this integral is a technique that you would learn in, if you're a BC calculus student. But we would use separation of variables for this equation. So just one thing, I would factor out a y like this, and the way you would do this integral is I would say, well, 1 over y times 1 minus y is equal to 1 over y plus 1 over 1 minus y. Does that work? Yeah, this works. If you do a common denominator and add these up, it will turn out it will work this way. And so what you're allowed to do is you're allowed to take the integral of both sides when you do this. So this becomes the integral of 1 over y plus 1 over 1 minus y dy. And this becomes the integral of dx. So you don't need to know how I converted this to this, but once you have it in this form, you should be able to do the integral. And my end result is the integral of 1 over y dy is natural log absolute value of y. This is negative natural log absolute value of 1 minus y. And that's because if you think about doing the derivative, it's going to be 1 over 1 minus y times negative 1. And that would make it positive 1 over minus y. And then the integral of dx is just x. And then we put our constant of integration over here. And so it's pretty tough to, I would combine this by dividing these two, by combining this in a single natural log, 1 over 1 minus y is equal to x plus c. And then I would do e to the both sides to cancel out the natural log. So I'm going to get y over 1 minus y is equal to e to the x plus c. Sometimes we write this as e to the x, e to the c, because that's what we can do. In this e to the c, we just make some other arbitrary constant, like that. Because e to the c is an arbitrary constant. C can be any value, basically. The only way you would determine it is if you had a specific initial value. So I can just call this some other arbitrary constant. And then I would solve for y at that point, right? So I'm going to leave that alone, but you can solve for y by bringing it here, by multiplying and doing some algebra to solve for y. Okay. So let me make a little more space because that required more space than I was expecting. So let's look at the next one here. So here we have to see well, can I group everything together? So first of all, I want to solve for y prime. Y prime, I'm going to group these together. I'm going to get y plus 3 plus ln of x. And then bring this to the other side is equal to y plus 3 ln of x plus x sine y. And so if you think about this, this is going to be dy dx times all of this, y plus 3 plus ln of x, is equal to y plus 3 ln of x plus x sine y. Note that there's nothing I can do to multiply to get all the x's and all the y's together by themselves. First, I'm going to multiply by dx, right? So I'll bring the dx up to over here. That's my first step. But you see, because the dy is multiplying by all of this, I can't divide to get ln. If I divide, I can divide by this whole thing, but then I'll have y over here, which isn't what I want. And same thing over here. There's no real combination that I can see that I can combine these two. So cannot be solved or cannot use separation of variables. Generally on the AP Calculus exam, on a free response question, if they're going to ask you to solve a differential equation, you ought to be able to use separation of variables, or they will give you a solution to verify. Okay, that's the other thing that they might give you. Okay. Let's look at this one. This looks very simple, right? It seems like I should be able to, this is a very simple differential equation. But think about it this way. I got to multiply. The first step is always to bring the dx up over to here. That's like, you cannot do that because the dx needs to be on the numerator. And you see, I can't divide by anything to get y by its. See, I can divide by x minus y, but then x is over here, and I can't do that, so cannot use separation of variables. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.